Welcome to another episode of Mic Out. And as you see, I'm sitting here with my laptop again, reading from a script. I tried to do this video yesterday in the rain, and it was, I didn't really get to say much, so the result was very bad. So I wrote a script instead to get my point through better, I think. I'm becoming too much of a couch potato these days. So hiking is a perfect way to reverse some of the damage of having an office job and spending too much free time indoors sitting still. So in this episode I will be combining 3 of my hobbies: off-trail hiking, land navigation, map and compass, not orienteering per se, because I'm not that fit to run around the forest right now. But hiking off-trail with a heavy backpack and stuff is really good exercise anyway. And number 3 is radio communication. Now, how do you combine radio communication with off-trail hiking and land navigation? Well, that is a challenge for this episode. As an amateur radio operator, portable operation is quite common. However, it would be way too easy to just hike around, set up the radio in different spots and make a few contacts with other hams around the world, QSOs as we call them. Instead, there will be another radio operator at the other end who will send me to different reference points on a map that I will have to reach within a deadline and get another coordinate to go to. I will not focus on ham radio in this episode, but on license-free radio that can be freely used by anyone. Today I will be operating in a part of the frequency spectrum called HF, high frequency, which spans between 3 and 30 megahertz. You may have heard of VHF and UHF. UHF is ultra high frequency, which is where most walkie-talkies and even your cell phone operate in. As a ham radio operator and as a military radio operator, I love HF. And the reason is that the frequency span is just right to be able to use the atmosphere to reflect or refract back your transmission to Earth. So in essence, your transmission radiates from your from your antenna in all kinds of different directions all around the antenna, and some of that radiation goes into the atmosphere in what's called the ionosphere. And in essence it bounces off the ionosphere and goes back to Earth, allowing for very long range communication without some kind of repeating station in between. This is called skywave propagation. But HF is also suitable for just beyond line of sight communication in terrain, and will usually reach further than VHF and UHF, especially in hilly and heavily forested terrain. That is the reason I'm discussing HF today. Unfortunately, there is only one license-free alternative within the HF band in most countries, and that is CB radio. CB radio operates in the higher part of HF, which is actually very good for longer range communication in hilly forest. Frequency is around 27 megahertz, which is also commonly called the 11-meter band, as one wavelength is around 11 meters long. A fully sized dipole antenna for CB radio is slightly longer than 5 meters. So it's not like the small UHF antenna in your cell phone, which a full-size dipole would be basically that length. So it's a huge difference in antenna size. CB radio is or was traditionally used in vehicles, allowing for their long antennas. Today in Sweden, CB radio, there's very little activity in CB radio, but in Europe there's a lot of high power, not very legal activity in this band, since they use way more than the legal power limit. Interference from these stations through skywave propagation is more significant than if they would have used the legal power. But if you use CB for non-critical long-range communication, it's still usable, since skywave propagation in this part of the band only happens during daylight, especially in summer. So if you need to use CB radio for long-range communication, nighttime would be the best time for traffic. Essentially, you would use some other license-free option during the day, only communicating within your group, and wait to send your critical long-range communication at nighttime instead. In military comms, the soldier may have an internal group radio talking to his or her group, usually in the high end of UHF or even SHF, super high frequency. The platoon would have an operator, typically with a VHF radio, to communicate with company staff. The company radio operator would have at least two systems, one to communicate down to the platoons and one to communicate up to battalion. And that radio may be an HF rig, depending on distance and terrain. So usually HF is used for long-range comms and UHF is used for shorter ranges. There is not a single band or single radio that can be used for all scenarios. There are several license-free UHF alternatives, but most countries have limited or no license-free alternatives for VHF. As a prepper, I believe it is a very good investment to own a couple of CB radios and play around with them. They are fairly inexpensive and use external antennas. Most other license-free radios out there, like PMR or FRS, don't allow you to change antennas. And CB radio allows you to play around with HF and even test or build your own antennas. Also, most CB radios can be modified to increase transmitted power and transmit outside of the legal band plan. I won't tell you not to do it, but I urge you to learn and experiment with an unmodified rig and the legal power limit, and save the mods for the apocalypse when you may need them. If you want to take it further, get a ham radio license and you have a lot more options than high power CB can offer. Let me introduce you to the radio operator in the other end. Sierra Alpha 6, Mike Whiskey Alpha. Gertrude, this is Mike Whiskey Alpha. Radio check, over.
Mike Whiskey Alpha, this is Gertrude. Lima Charlie, out.
Gertrude is a virtual radio operator. It's a computer program with speech recognition connected to a radio interface, which in turn is connected to a transceiver. Gertrude also features a simple cryptographic system called KK, which stands for Kilo Alpha Cipher and Authentication. Maybe the name is a bit exaggerated. It's not that bad, but not unbreakable either. It's vulnerable to frequency analysis. The cool thing about Gertrude is that I can use telephony to communicate with a computer. Normally you need to send a data message through some kind of device or a computer as written text. And you type SMSs on a cell phone in order to send data messages. Most readily available transceivers today use voice as a primary mode. For this episode, I have programmed Gertrude to send me to random reference points on a map. When I arrive to the reference point, I am to report my position, and Gertrude will send me a new reference point to go to. As Gertrude knows the coordinates, Gertrude also knows the distance, which I've used to set deadlines. So it's a different kind of orienteering game, I guess. In order to avoid CB interference, for this video I have relocated to the 10-meter amateur radio band. CB radio was 11 meters, and close to it we have the 10-meter band that we as hams, as amateur radio operators can use. CB was around 27 megahertz, and now I'm instead operating on 29.265 megahertz. This little mobile transceiver, a CRT Millennium, has been modified, making it possible to use the 10-meter band. As a ham radio operator, I am allowed to modify a transceiver and use it on the amateur radio bands. First, I will call and send an encrypted message telling Gertrude where I am right now. And right now I am at the reference point Victor Alpha. I will have to use the KK cipher and construct my message. After a while, Gertrude will instruct me to go to another reference point. So in the near future I will release the source code for Gertrude and the KK cipher. Both are written in Python, but for now they are just prototypes. Sierra Alpha 6 Mike Whiskey Alpha. Gertrude, this is Mike Whiskey Alpha. Message Lima Yankee Whiskey Quebec Yankee Sierra Tango Alpha Whiskey Sierra. Over.
Mike Whiskey Alpha. This is Gertrude. Copy. Message follows. Stand by. Mike Whiskey Alpha, this is Gertrude. Message. Sierra. India. Alpha. Romeo. Yankee. India. Alpha. Kilo. Yankee. Juliet. November. Echo. Bravo. Quebec. India. X-ray. Kilo. Bravo. November. Foxtrot. I say again. Sierra. India. Alpha. Romeo. Yankee. India. Alpha. Kilo. Yankee. Juliet. November. Echo. Bravo. Quebec. India. X-ray. Kilo. Bravo. November. Foxtrot. Out.
Gertrude just sent me an encrypted message, and now I have to decrypt it using the KK cipher. So in this case, the time frame here is it's almost 9 o'clock, and this sheet here is for from 800 hours to 1559. We're going to use box Sierra. Then we just have to this will take a while to decrypt. It's a manual, hand cipher, nothing complicated. You can do it when you're drunk or exhausted physically, so it's a very it's a simple cipher. So first is India Alpha, that's India, and that's Alpha, that's a G. And then we have Romeo Yankee, that's a 2. So G2 is a command that Gertrude sent me, which is go to. So the next part of the message will be a reference point and a deadline. Gertrude wants to send me to reference point Golf Alpha, and the next part of this message will be a timestamp. So Juliet November 0 Echo Bravo. So Echo Bravo here is a change that instructs me that I have to change the group. So Echo Bravo, and the next group will be Quebec. And I have to go to Quebec up here, and then continue with India X-ray here. India X-ray is a 9, so 900 hours sometime. Kilo Bravo 3. November Foxtrot. November 8. Gertrude wants me at reference point Golf Alpha no later than 0938 hours. So let's pack up and head out. So this is the antenna I'm using. It's a very simple type of antenna. It's a vertical dipole, or actually it's a vertical resonant feed line dipole. I will not go into antenna theory or antenna design right now. It's I mean, it's a science by itself, but a dipole has essentially two legs, two parts of the antenna. One part is the radiating element, and the other part is the counterpoise, so to speak. They are of equal length. The typical type of antenna you would use is a quarter of a wavelength. So I'm using the 10 meter band here. A quarter of that wavelength is 2.5 meters, approximately. It obviously depends on the frequency. So you take 300 and divide it by the frequency in megahertz, and then you get the wavelength. And you divide that by 4, and you get the part of the radiating part of the antenna that you usually use. So this is a quarter wavelength, and it goes until here. So this is the radiating element. Then this is a sleeve dipole. So you have this here is just a normal what's it called, copper wire. It's insulated, so it's black insulation. And then here it's soldered and yeah, heat shrink tubed, glued together with the inner part of an RG58 RF 50 ohm RF cable. There's a shield on this cable, and the shield goes above the lead of the RG58 cable. So it breaks here, and here starts the shield. And in this case, why it's called a resonant feed line dipole is because the outer part of the feed line, the shield, is radiating, is part of the antenna system. This is the counterpoise part. It's also 2.5 meters. Then it ends up in this coil. Now this is there are many opinions about these coils, but for this frequency, for CB radio frequency, 27 megahertz, and for 10 meter band, this type of air coil on a form, yeah, it's a 110 millimeter sewage pipe. The RG58 cable goes 5 turns around this form. This prevents the RF from traveling further, and it actually terminates the antenna right here. Well, sort of anyway. It works very well, actually. Even if it's not a resistive load, it's you add some inductance to the system. It's obviously an air coil. So, but for this frequency, these coils work quite well for this type of antenna. I would not advise you to use this type of coils or this type of antenna, resonant feed line dipole, for VHF or UHF. It will probably not work very well. And here you have the transmission line, and it's the same RG58 cable, so it just continues into a PL259 connector, and that is what you connect to an SO239 connector, which is on the back of your CB radio or ham rig or whatever you have. So that's it. Now I have to hurry up if I want to go get to Golf Alpha. So yeah. By the way, this is how you coil stuff. So yeah, this line I also have some kind of weight here and throw it up a tree. You dangle it. Yeah, well, you see me do it. So yeah, this is a way to coil your stuff. Maybe I should have taken the paracord off this thing. Now it's obviously an antenna that I'm coiling. It doesn't really work that well, but yeah. So in this way you don't get any kinks in it, and of course when you roll it out you have to roll it out like I did in the beginning. So then you have a nice coil like that, no kinks, ready to go. So okay, so I'm ready to head out. Before we continue, you probably saw me wearing this radio before. This is also a CB radio, but it's a hand transceiver. What's good about this is that it's actually water resistant, so it will handle rain pretty well. And you can see that this antenna is not 5 meters long. It's way shorter, and the reason is that it's got a coil here in the middle, and that coil shortens the physical length of the antenna. So electrically it behaves like a quarter wavelength antenna, but since it's shorter and it adds this coil here, the performance of this antenna is nowhere near the full length antenna, and so you have to be aware of that. But this allows me to, you can walk around with it. And this type of CB radio, the antenna you saw earlier that I demonstrated, the wire antenna, I have one up in a tree at our house, at our country house where I am right now. And that is our communication for this area. The cell phone reception here is extremely spotty. So even if we are in one of the world's best countries for cell phone coverage, right here it's actually not that great. So we don't have any cell phone coverage around our house, actually. And then we use radios to communicate. And even though this antenna is short, the terrain here is perfect for CB radio frequency, 27 megahertz. So that way I can communicate with my wife in the house when I'm out here, and we don't need to rely on the spotty cell phone coverage that we have here. And anyway, you can't call using your cell phone from the house. But let's head out to Golf Alpha. So I'm somewhere near Golf Alpha at the moment, and yeah, I will use this tree to get my antenna up there. If you wonder what this is, it's hunting season right now. Well, maybe not actually yet, but I heard there were dogs out, so they are hunting boar right now, I think. So I have to construct the message, and the command that I will send to Gertrude is AT and my reference point. AT is a command for, you know, at and the reference point. Let's take this group. So where do we find an A? Here, A, uniform linking, T, Zulu, November, at G, Mike, Quebec, Alpha, uniform, X-ray. Let's transmit. Sierra Alpha 6, Mike Whiskey Alpha, Gertrude, this is Mike Whiskey Alpha, radio check, over.
Mike Whiskey Alpha, this is Gertrude. Good, readable, out.
Gertrude, this is Mike Whiskey Alpha, message, over.
Mike Whiskey Alpha, this is Gertrude. Send your message, over.
Sierra Alpha 6, Mike Whiskey Alpha, Gertrude, this is Mike Whiskey Alpha, message, Mike, Kilo, Uniform, Yankee, Zulu, November, Mike, Quebec, Uniform, X-ray, acknowledge, over.
Mike Whiskey Alpha, this is Gertrude. Copy. Authentication. Quebec. Foxtrot. Alpha. Whiskey. I say again. Quebec. Foxtrot. Alpha. Whiskey. Message follows. Stand by. Mike Whiskey Alpha, this is Gertrude. Proceed to reference point. Victor. Romeo. Not later than 10:19 hours. I say again. Proceed to reference point. Victor. Romeo. Not later than 10:19 hours. Out.
Okay, so Gertrude wants me at reference point Victor Romeo, not later than 10:19 hours. So that was a message in clear. It was unencrypted, so it was just easily copied. No need to decrypt anything. And obviously no one knows where reference point Victor Romeo is except the one who has the map. Yeah, you may wonder what the Morse code is in the beginning of Gertrude's transmission. And that is my call sign, Sierra Alpha 6, Mike Whiskey Alpha. Since I'm on the 10-meter amateur radio band, I have to identify my transmission. So one way to do that with machines is to have a preamble with CW, which is Morse code. So that's also why I'm starting my transmission with Sierra Alpha 6 Mike Whiskey Alpha, because Gertrude is more set up as a military sort of comms thing, and uses more traditional military call signs, or at least here, except that Gertrude is called Gertrude. But yeah, so that's what I'm doing on the ham bands. And for CB radio, you don't have to use any call signs. You can just freely transmit and say whoever you are. You can say that you're Donald Duck and whatever. Yeah, that's. And by the way, Donald Duck is Kalle Anka in Swedish, and the cipher is called Kilo Alpha. So Kalle Anka becomes Kilo Alpha. So it's more like a not very serious type of encryption. But yeah, it serves the purpose, and yeah, it's Gertrude can copy it quite fine, I think. That's nice to hear, even though we are several kilometers from Gertrude's transceiver right now. So yeah, Victor Romeo it is. So Victor Romeo is back from where I came, and it's about 500 meters, so not that difficult. Time to move. Sierra Alpha 6, Mike Whiskey Alpha. Gertrude, this is Mike Whiskey Alpha. Message, over.
Mike Whiskey Alpha, this is Gertrude. Send your message, over.
Gertrude, this is Mike Whiskey Alpha. Message, Lima, Yankee, Whiskey, Quebec, Yankee, Sierra, Tango, Hotel, Whiskey, November, over.
Mike Whiskey Alpha, this is Gertrude. Copy. Message follows. Stand by.
Okay, so now Gertrude will send me an encrypted message. I have to copy this one.
Mike Whiskey Alpha, this is Gertrude. Message. Juliet. Lima. Romeo. India. Whiskey. Yankee. Quebec. Bravo. Lima. Romeo. Lima. Whiskey. Charlie. India. Quebec. Quebec. Bravo. Mike. Oscar. Bravo. November. Foxtrot. I say again. Juliet. Lima. Romeo. India. Whiskey. Yankee. Quebec. Bravo. Lima. Romeo. Lima. Whiskey. Charlie. India. Quebec. Quebec. Bravo. Mike. Oscar. Bravo. November. Foxtrot. Out.
So basically half an hour we have to be at Victor Uniform. So my next reference point is Victor Uniform. And let's see. I'm heading back to where I came from again. So yeah. Okie dokie. I'm Oscar Mike. So somewhere out there is Victor Uniform, and I will set up my antenna here in cover of the forest. This will be the final call, since I have another deadline. I'm about to break too. I promised my wife that we'd be leaving or start packing no later than 1100 hours. I will break that deadline too. It's really difficult making these videos. I thought I would be a lot faster. And the distances on this radio game, they are not very large. I mean, 1 kilometer in terrain, it obviously takes a while, even if you're not filming. So yeah, and setting up these areas is more difficult than just using a hand receiver like this one. Sierra Alpha 6, Mike Whiskey Alpha. Gertrude, this is Mike Whiskey Alpha. Message, Quebec, Quebec. Tango X-ray. Foxtrot Sierra. India Sierra. Kilo Tango. Over.
Mike Whiskey Alpha, Mike Whiskey Alpha. This is Gertrude. Copy. Message follows. Stand by. Mike Whiskey Alpha, this is Gertrude. Message. Mike. Kilo. Mike. Foxtrot. Zulu. India. Bravo. Whiskey. Alpha. Oscar. Tango. November. Tango. Quebec. Uniform. Whiskey. November. November. Quebec. Foxtrot. Alpha. Lima. I say again. Mike. Kilo. Mike. Foxtrot. Zulu. India. Bravo. Whiskey. Alpha. Oscar. Tango. November. Tango. Quebec. Uniform. Whiskey. November. November. Quebec. Foxtrot. Alpha. Lima. Out.
So that means I have to decrypt this for continuing. Gertrude wants to send me to reference point Romeo Victor, but yeah, I think I will call it a day, and I want to have lunch. I brought US MREs just because I got this in as a birthday present from my wife. I wanted the real thing, I said, and you know, she could find any MRE from any army around the world. She got a box of the A box of US MREs, and actually I didn't know that it's US government property. Commercial resale is unlawful. Hopefully these are not stolen anywhere, but they came directly from eBay. According to the design and the date stamp and everything, these are from 2017. It's menu number 1, chili with beans. I would say that it's a different kind of taste than we are used to. We have a type of MRE bag in the service here too. It's just a different setup. It's a 24-hour bag instead. I will probably do a video on that in the future. Peel is not my thing. So the flame is into bag. What's this? This is some kind of cornbread and chili with beets. What do we have here? Pepperoni pizza crackers and the sleeve, and we have matches, and I don't know if I had matches in the other one. Spoon, yeah, we can use this one. Vegetable crackers. you need water for this, and water. The ones we have in Swedish Army are from this Danish brand Orifo, and they're a little bit larger than this one. But they also, you're supposed to put the thing you want to heat inside the bag before pouring water in. And I think you should do the same thing with this one. Yeah, you should. It's a bit tight. I don't fit too loose in this one. I guess that's why they have this sleeve. But I want to heat something else. No, it's nothing more that I want to heat. I want to use put water in that one. More water than I should have put in there. Actually, maybe I should have put the bag in the like that, I guess. So what do we have more here? We have more beverage, cheese spread. Okay. That's actually not bad. That works. These small pepperoni pizza crackers. Yeah, well. Aye, that's what. So, well, the batteries on the cameras are running out. So, yeah, with this meal here, I'm signing off. And I hope you enjoyed this episode. And leave questions in the comment field below. If you want me to do anything else, especially radio comms, and maybe go into more detail about anything that I've demonstrated here today. Well, that's it for this episode, and this is Mike, out. Mm-hmm.